Okay. Hey guys, in today's lesson, all right. Okay, this is gonna be awful. So in our video lessons that we're doing here now for Mrs. Goldstein's third period, that my second period is watching me do, is very awkward for me. So just bear with me as we go through this. We're gonna. I can't. I gotta stop. I gotta stop it for a second. So what? Yeah, I know. Okay, listen. I'm just gonna go ahead and tell everybody let's watch this video. This is weird for me to record myself teaching. So I'm just gonna pretend like this video is not even happening right now. So good luck to whoever's watching this, not live. So good luck to all y'all. I'm gonna try to yell into the mic so you can hear me. They're not there. They're not there. They're not there. All right, they're not there. All right. So the explicit. Okay. So just to recap. This was the recursive formula here in arithmetic sequences. The explicit formula was a sub n equals a sub 1 plus n minus 1 times our common difference. Okay? Times our common difference. And we use the explicit formula to find any nth term. Okay, that's why it was very helpful. And the recursive formula is great and all, but it's all it really is useful for is just telling us what. Remember? The common difference. That's all it's useful for. It's just telling us what we do to go from our previous term to our next term. In this case, we would add 7. So this is our common difference. Okay, so take a second, see if you can maybe use the explicit formula to try number 1. See if you can work backwards with your explicit formula again in number 2. Okay, and then we'll figure it out together. Alright, so for solving number 1, we're trying to find the 35th term. Okay, really we only need 3 things, right? We need our first term, we need our end value, we need our common difference. As long as you have those 3 variables, you're set. Okay, so what is our first term in this case? Yeah, 16. So 16 right here, plus, what is our end value in this case? Yeah, 35, that is our end value, that's what we're solving for. And then our common difference is what? Yeah, we're subtracting 5 each time. Okay, so I'm going to put a negative 5 right here. And this will find us our 35th term. What y'all get? Negative 154? Yeah, it makes sense to me. I mean, we're going down by 5 each time, so our 35th term is going to be negative. It makes sense that it's a negative big number there. So, yeah, any questions on that one? How do you set that up? As long as you know explicit formula, please just make sure you're taking good notes. Okay, take good notes, write all this stuff down. Keep it separate somewhere with the formulas. Maybe in a nice clean box that's square or circle that you can easily access for like homework and stuff, right? Okay. Any questions on number 1? All right, number 2, it says, using a sub n equals a sub n minus 1 plus 7, find the first term in the sequence if the 5th term is 44. Okay, so again, this formula right here is recursive. All it's good for is just telling me that common difference. Now, if we're ever trying to find any term, even the first term, any nth term, I think the explicit formula is your best bet. Okay, so remember the explicit formula was a sub n equals a sub 1 plus n minus 1 times our common difference. So we need to identify 3 variables here. Okay, we're looking for a sub 1. We need to find our a sub n. We need to have an n value and a common difference. If we can find those 3 things, we can solve for the first term. No problem at all. All right, well, let's start easy. What's our common difference here? 7, yeah. All right, so 7. Now, the other ones we need is the a sub n and the n. Do we have, that just means a given term in the sequence. Do we have a given term in the sequence? Yeah, we have n equals 5, and we have the value of that 5th term is 44. All right, whenever it gives you something like that, we have it gives us 2 things. What our n value is, what the a sub n value, it gives us a term that we can use to work backwards. So that would be 44 here, and 5 right here. Okay. So to solve this, we got 44 equals a sub 1 plus 5 minus 1 times 7. That makes sense? All right, and then solving from there, let's simplify down this piece first. We get 4 times 7, 28. So we got a sub 1 plus 28 equals 44. And for my final answer, what'd y'all get? I got 16. Make sense? You could have worked back. I mean, like in this case right here, like you could have worked backwards. Like you're only at the 5th term. Like that wouldn't have been too hard. Like 1, 2, 3, 4, 5. Like if this is your 5th term, it's not hard to work backwards a few numbers to get to your first term of 16. You can just subtract 7 a bunch of times. But if I give you like a 200 term, that becomes unreasonable. All right. So just make sure you know how to read a recursive formula. You know what the explicit formula is, and we'll be set. In today's notes, all right, they're not as long as the arithmetic notes because now we know what a sequence is. But the pattern we're talking about today is a geometric pattern. Okay, so we know what arithmetic is. We know it's when you add or subtract the same number each time. The second type of pattern that we need to know how to do is a geometric sequence. Okay, it's the same exact definition, but what I've underlined is the only difference. Okay, so it's a list of numbers still that have a common ratio between consecutive terms, meaning ratio is a rate, meaning I'm multiplying by the same thing each time, and that's really about the only difference. Okay. Now we can't divide by the same thing each time. So what do you think? How do you think we would like do that? Like say it's dividing by 2 each time. We're not really multiplying by 1/2. So we're multiplying by numbers to make it bigger, like whole numbers to make it bigger, or fractions or decimals to kind of show dividing, okay, and make them smaller. Just like with arithmetic, we have 2 formulas. We have the recursive formula and the explicit formula. Those 2 formulas. If you notice, the explicit formula is the same exact setup as the arithmetic one. We still have a sub n equals a sub n minus 1. But instead of like plus some number, we say multiplied by some number. Okay? So this means take your previous term, multiply it by some number to get your next term. The only thing that this is really helpful for, besides just knowing how to make the formula, is that it tells us our common ratio. Okay? It's the only really decent thing for it. The really important one, the one that you kind of need to know how to make to find any nth term, is your explicit formula. Still the same setup. We have a sub n equals our first term, whatever it is, and it says multiplied by r to the n minus 1. I like to kind of put that in parentheses. That's how I write it. So that's saying a sub 1 times our r value raised to the n minus 1 power. Yes, ma'am? Yes. They know. Any questions on that? Just find any terms are okay about that. Makes sense. Okay, let's do some problems. Just the same site that we did last week. Let's just do a bunch of problems, practicing all the different things that you can see on the quiz, test, or whatever. So you can have those available and understand what's going on. So in this problem, we want to write the explicit formula for each, and then find the first 4 terms. Okay, find the first 4 terms. So it's not too bad. If you're ever writing the explicit formula, really, you only need to know 2 things. Your a sub 1 and your r value. If you know those 2 things, you know what the explicit formula is. You just plug them in and you got your answer. Right? The explicit formula, okay, just generically, a sub n equals our first term times our rate to the n minus 1. As long as you know those 2 numbers, have your explicit. Okay? And explicit is in terms of n. So in this case, our explicit would be a sub n equals my first term, which is 100, times my rate, which is negative 20, to the n minus 1. That's my explicit formula. That's the formula that would tell me the value of any nth term. Okay? Let's do the first 4 terms. A sub 1, well, it gave us that, it's 100. A sub 2, if I want to know a sub 2, that's a 2. Plug 2 into the formula, so that's 100 times negative 20 to the 2 minus 1 power. And all it's really doing, I mean, 2 minus 1, that's just 1, and negative 20 to the first power is just negative 20. So all this formula is really saying to do is just do 100 times negative 20. or our first term times our rate to get our next term. That's what the formula is doing for us.
Teachers, may I have your attention?
So in this case, this equals negative what, 2,000? Okay. So our second term is negative 2,000. If I want to do my third term, again, I can just plug it into the formula. A sub 3 equals 100 times negative 20 to the 3 minus 20. And really what that's doing is that's raising it to the second power, which is saying do 100 times negative 20 and then times negative 20 again, because that's what it means to be squared as you multiply by. It's just doing the pattern multiple times, which in this case I believe is positive 40,000? I think it's positive 40,000. Is it positive? Should be positive. I think it's positive. So you do 100. Make sure you type it in exactly like you wrote it down. Negative 23 minus 1. Okay. And it should make sense because we're multiplying by negative 20 each time, so the signs aren't changing because we multiply by negative, it changes sign. Negative 20 and then positive 40,000. If I'm doing my fourth term, that's 100 negative 20 to the 4 minus 1, or to the third power, which I believe is negative 800,000, right? So let me check my math on that. Any issues with that? And you can even see the pattern happening. Like we're going from 100 down to negative 2,000, down to 40,000, down to negative 800,000. We're just multiplying by negative 20 each time. Okay. So any issues there? Okay. Let's try this next example right here. Yeah, I wonder how many people actually can watch this video. Still recording. Okay. Let's try this next example. Alright. Write in the explicit formula, we need those two things. Hey, those two things are given. Our first term and our rate. Okay? This is our explicit. Let's just plug those bad boys into it. That's a sub n equals my first term 1/2 times my rate, which is 2/3, to the n minus 1,000. It's the same. My first term is 1/2. To get to my next term, I multiply by 2/3. And I keep doing that on and on. So let's think about that pattern as we're finding our first through fourth terms. So I want my first term, well, it's given to us, it's 1/2. And I'm going to think about this recursively, which means just to do the pattern. My second term, a sub 2, would just be my first term times my rate. That's really all it is. Okay, and that's how we get to the next term. Just a side note there, if you multiply fractions, you multiply the top, the bottom, so 2 6 for 1/3. So my first term is 1/2, my second term is 1/3. If I want my next term, okay, that's 1/3 multiplied by our rate again, which is 2/3, which is 2/9. And my last term would be that multiplied, so 2/9 multiplied by our rate again, which was 2/3. And finally, I'm getting 4/27. Not too bad. So what do you think about that? Too much. You just walked in. All right, this next step here. So given a list of numbers, we're going to find the 18th term, the 23rd term, and the nth term. So these are just common examples that you see on the test, okay? So make sure you're taking good notes. Make sure everything's all right. So, okay, for the geometric sequence, so if I need to find any nth term, remember the explicit formula is the one that we're going to be using. A sub n equals my first term times my rate to the n minus 1. So if you can fill in all those variables, you can find any nth term. All right. And those are the only three variables we need to know. All right, so what's my first term in this first one? 1 is just the first number, okay? What's my rate? What am I multiplying by each time? Yeah, multiplied by -2, multiplied by -2, multiplied by -2. It is -2. Now, in this case right here, I think that it's pretty obvious to see what the pattern is. I think you can just tell by looking at it. Sometimes it's not going to be so obvious, especially if you're dealing with fractions or weird decimals or something like that. How can you always figure out what your rate is by doing just a little bit of math? Think about how we did our common difference. We would just subtract consecutive terms. What would we do here between consecutive terms? Divide. Yeah, I mean, take any two terms. Take 4 and -8. So you're going to take your second term, -8, divided by the previous term, and it'll always give you your rate, whatever it is. Okay? Just keep that. All right, what's our end value in this case? Very good. 18. End value is just a number term we're looking at. Okay, so we got the 3 numbers we need. We can find the 18th term, no problem. All it is just a sub 18, my 18th number, is equal to my first term. I should probably talk this way. Is equal to my first term 1 times my common difference, which is, or not my common difference, my rate, which is -2, to the n minus 1 power, 18 minus 1. I don't have that answer. I think is it negative?
Yeah.
Negative 100 and something thousand?
131,000.
That?
Yeah.
That's good to me. What's up? Let's do our 23rd term. 23rd term is the same exact thing. Same exact process. It's just what value's changing. And it's now 23, right? So that's going to be a sub 23 equals, our first term is still the same, it's still 1. Our our rate is still -2, but now it's to the 23rd minus 1. It's a little bit farther down the list, so I expect that number to be a little bit, I guess, bigger, maybe positive, maybe negative, but it's a bigger number. What do we got?
4,194,304.
94,304. Beautiful. All right, questions on those? I asked this question a lot right here too. The nth term. What do I mean when I ask for the nth term? What does that mean? The formula. If I ask for the nth term, I'm just asking for the explicit formula. It's just a fancy way of me saying, hey, write the explicit formula for this situation. Which we have, we just don't put a value in for n. So that's just a sub n equals our first term times our rate to the n minus 1. Okay. Questions on that? All right, so next problem is very similar to the one we just did for warm-up. Okay, it's a very common problem. I'm giving you, this is really the only application that I would ever give you the recursive formula. Okay, again, this right here, it says using a sub n equals -2 times a sub n minus 1. That is your recursive formula. Okay, if you ever see the n minus 1, you should be thinking recursive. Okay, and really the only thing that's helpful for is just telling us our pattern. In this case, our common ratio. So I can identify from this formula that r is equal to -2. So using that information, and the fact that a sub 4, our fourth term is 32, find the first term. Okay. So finding the first term, it's still helpful to know our explicit formula here, which again was a sub n equals my first term times my rate to the n minus 1. Hopefully you have that readily accessible, okay, readily available. Another side note I kind of want to mention real fast. Remember how we talked about arithmetic sequences? Okay. Remember how we talked about with arithmetic sequences that they are linear, right? That they follow a linear approach. So arithmetic is a linear equation because it follows a slope that has a common difference each time, which is the same. So it's linear because it has the same slope each time. What does this formula look like? What kind of equation does this look like? If you think back in the day, what kind of equation is that? We'll talk more about this later on, but It is growing exponentially. Yeah, if you ever had the variable of power, it's an exponential equation. So just kind of keep that in the back of your head. But anyway, let's think about this. So if I want to solve for my first term, a sub 1, I need to have a few variables. I need to have my ratio, which I just figured out. And I need to have some term given to me, which it is, just like in the warm-up. Okay? So we know that n is equal to 4 in this case, and that a sub n, that fourth value, is equal to 32. I can plug in all those numbers and solve backwards and work backwards to find a sub 1. All right, so just plug in everything I got. I got a sub n, or 32, equals my first term, which I'm looking for, times my rate in this case was -2, and to the n minus 1, or 4 minus 1 power. Okay. All right, that's easy to solve. I would recommend maybe simplifying down this piece first. -2 to the 4 minus 1 power, or -2 to the third power, which is what? -8. And then I feel very confident that we can all solve it from here, maybe. Divide everything by -8. And then our first value is equal to -4. And I think it's very helpful to know how to use that formula, because I may give you a really big number in the sequence. This problem wasn't too hard to work backwards just thinking about it. I mean, if I'm giving you the first or the fourth term is 32, and you know that the rate is -2, you can work backwards. Just divide by -2 a bunch. -16, +8, -4, and you end up getting the first term in the end. It's however you want to do it, but I think knowing the formula is your best bet, especially to get full credit, or partial credit, at least if you miss it. So. Questions on that? Comments on that? All right, I'm only going to do I don't know, we'll go through these pretty quick. The determinant of the sequence is arithmetic, geometric, or neither. If possible, write the formula for the nth term. So if I ever say this, I'm asking for the explicit formula. Okay, that tells me any nth term. And here we're just bringing back what we talked about last week. So these patterns on these 5 problems here are really super easy, I think, to recognize. For the test, it's not going to be as straightforward, so you just got to make sure, I might try to trick you at least. Okay, so you got to make sure that whatever pattern you have is obvious and consistent throughout every single number, okay? I don't want to trick you, I like to be a jerk sometimes. Okay. So, in this problem here, okay, we're going 45, 90, 180, 360, it's a common difference, but we're multiplying by 2, right? Multiplying by 2 to get from one term to the next. So this does make it geometric. All right, we know the geometric explicit formula. All I need is my first value and my rate. So that's a sub n equals my first number, 45, times my rate, which is 2, to the n minus 1. That's it. That's all you got to do. Yeah. Now you can use that anytime you want to find any nth term. All right, let's do just number 2 and number 4. Yeah, so number 2 is 25, 50, 75, 100. That's what, arithmetic or geometric? Arithmetic, because we're going up by a common difference. Okay? In this case, we're adding 25. So in this case, this a sub n equals, well, my first term, which is 25, plus n minus 1. What's my common difference? Well, I just said it. 25, right? We're adding 25 each time. That's it. Any questions on this so far? All right, the last one that I want to talk about on this problem is number 4. I just think that's kind of a cool pattern. It goes 3, -3, 3, -3. What's going on? What's happening? Contradicting. Very good. Thank you. What if it was 3, 3, 3, 3, 3, 3, 3, 3, 3 times 1, or add 0? Yeah, that one could be arithmetic or geometric. Right? But here we're multiplying by -1 each time. That makes it geometric. So our explicit would be our first term, 3, times our rate, -1, to the n minus 1. That's actually called an alternating series, because it alternates between positive and negative, and alternates between two values. Not really important for us to know, but if you ever take calculus, that's important. Alternating Taylor series? Okay, whatever. Questions on this? The last thing I want to talk about today is the geometric mean. Now, this is a lot like the arithmetic mean and the problems you had on your homework, okay, where you had to find the missing term in between two numbers, okay. But this is used in the geometric sequence, and if you think back to our apportionment unit, we have seen geometric mean before with the Huntington-Hill method. You round it using geometric mean. But what you do is you take the positive square root of the product of two numbers. Okay, so this is what it looks like, the square root of a times b. Then we use it to find the missing term. So let's look at this example. Find the missing term, 3 blank 18.75. The geometric mean will find that number in between them. It has a common ratio between consecutive terms. So I can take the square root 3 times 18.75. Well, I don't know if that equals
Square root.
7.5. I think it's 7.5. And so what I'm saying is like the same number it takes to multiply 3 to 7.5 is the same number it takes to go from 7.5 to 18.75. And you can figure out, you can make sure that's right. I mean, you could figure out what your rate is by doing 7.5 divided by 3. I think you get 2.5. So what I'm saying is it's the same number. Like you can do 3 times 2.5 and get 7.5 and multiply it again by 2.5. That's what we're doing. And then finally, the last one here, we got 3 blank blank blank, 243. We got 3 missing blanks. So if I do the geometric mean here, square root of 3 times 243, what number is that finding in that list? It's 27, which is the middle number. It's finding the one in the middle of it. Just like arithmetic mean, we find the one in the middle. So 27. And then I can do it again right here. I can do the square root of 3 times 27, which is 9. I think it's pretty obvious to see what the rate is now. Times 3, 27 times 3, 81. So there's my lesson. There's my lesson for geometric mean. Thank you, class, for paying attention. Goldstein's class, good luck. Stay tuned for more videos. Easy.